Hey, what's up? I'm Samuel, a junior computer science major. This semester, we are taking an introductory artificial intelligence and human interaction course. And I thought this could be the place where I could share what I've been learning, thoughts, and ideas. I want these videos to be both educative and fun. And so I'll jazz them up a little bit with the best of my videographer skills and motion graphic skills. Before I get into a topic, mostly I like to know how it came by, the history behind it, and the ins and outs of it. So before we get too into the weeds of what AI is and cut through the hype of what it can do and what it cannot do, it helps to know how modern artificial intelligence came to be. So let's take a history lesson.
A world in which a new machine, the digital computer, may be of even greater importance than the atomic bomb. Can machines really think?
I don't believe that we can say yet that machines do think.
I confidently expect that within a matter of 10 or 15 years, something will emerge from the laboratories which is not too far from the robot of science fiction fame.
The year is 1956, and a group of scientists and mathematicians have gathered for an 8-week workshop at Dartmouth College. The purpose of this workshop was dedicated to the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that the machine can be made to simulate it. In other words, how can machines be made to do what humans do? MIT cognitive scientist Marvin Minsky and the others who attended this conference were extremely optimistic about the future of AI. He wrote in the book saying, within a generation, the problem of creating artificial intelligence will substantially be solved. But achieving an artificially intelligent being was and still is no easy task. Some of the tasks were very difficult to achieve, and progress in the field slowed in 1974. After several reports criticizing progress in AI, the US Congress and the British government cut off funding and exploratory research in AI. The next few years would later become what is known as the AI winter, a period when obtaining funding for AI projects was difficult. And so what I kind of find fitting here is this graph, Gardner's hype cycle. When a new technology evolves, it goes through 5 main stages. One is the stage when there is so much media interest, mostly governed by ignorance or lack of knowledge in the field. Although there may be existing prototypes, but there would be no functional products. Then next, the stage where there is a lot of publicity about both the successful and unsuccessful implementation of the technology. Then the stage where flaws and failures lead to some disappointment in the technology. And then the stage where the technology's potential becomes so broadly understood and an increasing number of companies begin to test it in their environment. Then finally, the plateau of productivity, a stage where the technology is widely implemented and well understood. As we go through this bit of history, I want you to identify these overlapping stages. So back to our history lesson. It's the early 80s and research funding for AI has been revived by the success of expert systems. Japan's 5th generation computer also inspired the US and British government to restore funding for academic research. But the field once again experienced another second longer lasting winter because of the collapse of the market for some of the early general purpose computers like the Lisp machine. So some researchers were like, hold up guys, I think we're doing this whole AI thing wrong. What if instead of building systems that trains the same way as humans, that's using a symbolic approach, we instead looked into the sub-symbolic approach to specific AI problems? So instead of building a general purpose AI that can equally do things reserved for humans, they focused on breaking the task into much smaller fields like perception, robotics, learning, and pattern recognition. Now, fast forward to the late 90s to early 20th century, AI has become even more popular and has seen much success because of interest in neural networks, faster computers, algorithmic improvements, and access to large amounts of data. Even so that the primary goal of some AI research is now focused on artificial general intelligence, an intelligent agent that is able to understand or learn any intellectual task that a human being can. Alright, that's it for this one. In the next video, we'll see why and how all problems in artificial intelligence can be solved using certain algorithms. Subscribe if you want to see that one, I guess. Thanks for watching. Peace.